This video will go over different aspects of the DJI Agras drone. The Agras has a wide range of applications and is one of the world's most popular agriculture drones. It can be used for pest control, weeding, and spraying foliar fertilizers and defoliant. Using the spreader system, the Agras can also spread seeds, fertilizer, and feed. The Agras drone mainly consists of the flight platform and payload. It can be used for different applications by changing the payload. The flight platform consists of a flight control system, a power system, and a link system. The flight control system enables automated flight and other complex functions. The power system enables all drone operations like flight and spraying. The link system establishes a two-way connection between the drone and remote controller. Now, let's look at the different components of the flight control system. First, satellite positioning, or GNSS. It's what enables the drone to hover stably and operate autonomously. So you must ensure that at least 8 satellite signals can be received before each flight. However, the accuracy of satellite positioning isn't high enough to support high-precision flight. For much more accurate flights, RTK is required. RTK is a high-precision positioning signal with centimeter-level accuracy. Today, network RTK is often used, and a cellular data connection is required for communication. You may have noticed the two mushroom-like shapes on the T-Series Agras drones. These are the RTK antennas. The two RTK antennas enable the orientation function and highly accurate flights. They also prevent electromagnetic interference even when the drone is under high voltage lines. Without the RTK orientation function, the drone will need to rely on its compass. So, if the orientation function is disabled, you must calibrate the compass. Next, we'll go over the radar system. The Agras drone uses radar to sense its surrounding environment in real time. This enables forward and backward obstacle perception and avoidance. Downward-facing radar helps determine the altitude of the drone for auxiliary height determination. It also enables terrain-adaptive flight. So even if the terrain changes, the drone maintains the same height above ground. The batteries, electronic speed control, motor, and propellers together make up the power system of the Agras drones. The lithium battery provides power, the ESC controls the motor, and the motors drive the propellers to generate lift. Keep in mind that the lithium battery shouldn't remain fully charged for a long time, so the smart battery is designed with a self-discharge function. If you find that the rear panel heats up, it is because the battery is self-discharging to ensure its long-term use. Also, battery charging and discharging speed will gradually decrease in low temperatures, so it might take longer to charge your battery in cold weather. A multi-rotor drone changes direction by changing the speed of its different motors. For example, if the speed of the left motor is higher, the drone will fly to the right side. Usually, half of the drone's propellers rotate counterclockwise, and the other half rotate clockwise. Accordingly, propellers are divided into CCW and CW propellers. Before installing propellers, make sure that you align them with their motors correctly. The link system, or remote control system, helps the pilot control the drone and also enables image and flight data transmission. Please note that the remote controller signal is strongest at the sides of the antennas. So, during normal operation, avoid pointing the antennas towards the drone since it results in a weaker signal strength. Your Agras drone and remote controller have already been linked prior to delivery. You won't need to link them unless you change the remote controller. To complete linking, tap linking on the remote control app, and then press and hold the power button on the drone for 5 seconds. Finally, let's look at the spraying system. It consists of a tank, filter, water pump, and spray nozzles. The tank carries the liquid pesticide. The filter helps remove impurities. The water pump generates pressure, and the spray nozzles atomize the liquid pesticide. T-Series Agras drones are usually equipped with a pressure spraying system. We recommend using water-based pesticides to avoid clogging the nozzle. Now, let's go over the different parts of the spraying system. The flow meter is located between the tank and the water pump and is used to calculate flow rate for more accurate flow control. The level sensor checks the amount of pesticide remaining in the tank and can alert the pilot when the tank is empty. The T10, T16, and T20 have a single point level sensor, which can only estimate the remaining pesticide and can't display the exact remaining amount. The T30 uses a continuous level sensor, which can display the amount of pesticide in the tank in real time. It can intelligently predict when the tank will need to be refilled, improving efficiency and saving battery power. While the nozzles are small components, they have a major impact on spraying performance. The T-Series drones use SX110-01VS nozzles by default, where SX means that the nozzle is a fan-shaped, 110 means that the fan angle is 110 degrees, 01 is the flow rate and indicates the size of the nozzle, and VS means that the nozzle is made of stainless steel. Note that the smaller the nozzle, the finer the droplets, and generally the better the insecticide or fungicide spraying performance. However, the droplets are then more prone to drift and evaporation. The electromagnetic pressure relief valve is a component that opens and closes each nozzle. Generally, you can press and hold the spray button for 2 seconds to discharge the air before the operation. This is a conclusion of our Agras drone overview video. We hope this answered your questions, but if you have more, feel free to reach out to your local DJI agriculture dealer.